Hello, ladies and gentlemen. All right, hope my hello didn't wake you up too much. Okay, so I am excited because today you are going to be practicing simplifying identities, which you're probably like, Mrs. Fry, you are way too excited about this topic. And you're right. I probably am. But you should be too because it's awesome. Okay, so what I'm going to do is I'm going to show you the identities that you should know at this point. And if at any point in time you need to pause or go back, you could always take a quick picture, write these down, or just rewind the video and come back to this spot where I show you all of these identities. Okay, so these might be a lot to see all at once. So let me break it down for you, okay? You know the 6 reciprocal identities, okay? I've got sine, cosine, tangent, and then our reciprocals, cotangent, cosecant, and secant, all right? Key thing about it, your reciprocal is that it's 1 over the function it goes with, okay? So for example, cosecant goes with sine, so its reciprocal is 1 over sine. Notice that that's basically saying sine is in the denominator or cosine, whichever one you're talking about the reciprocal for. Okay, next one, quotient. Quotient is just a fancy way of saying division, okay? And the 2 functions that came from division, tangent and cotangent, are the ones we have a quotient identity for. So tangent, sine over cosine, cotangent, cosine over sine. And then last but not least, our Pythagorean identities. We've got 3 of those. So we have our original, sine squared plus cosine squared equals 1. And by the way, the order you write those does not matter. When I say that, I mean the sine and the cosine on the left-hand side. The 1 has to be all by its lonesome. 1, the loneliest number. All right, tangent squared plus 1 equals secant squared. That's what you get if you divide everything by, cosine squared theta, then you get this guy. And then last but not least, 1 plus cotangent squared, that's what you get if you divide everything by sine squared. Okay, so remember you only really need to know the top one and you can get the other 2 pretty quickly. Okay, so here's my plan. I'm talking to myself already while I'm making this video, but I'm basically going to talk through some problems, and the point of me talking through them is to begin to create your own inner dialogue where you are talking to yourself, and these are the questions you're asking yourself and answering while you're doing these problems. I strongly encourage you to pause the video, okay? Use the pause, not like in Star Wars when you use the Force. Use the pause button. Take a moment and think for yourself, okay? All right, so here we go. First problem. By the way, the goal whenever we're simplifying, that's what the directions are on this, is to try and get simplify to a single, that means 1, trig, ratio, or expression. So like if you look at the first problem, there's 2 things. In the second problem, there's 3 things. The goal is try to cancel everything out so you only have 1, a single trig function left. Okay, so the first thing you might say is, I don't even know what all that says. So if what you're reading is a little bit confusing to read, then maybe rewrite it. So for example, what this says is negative cosine of x. Okay, so that's one of our functions, times cosecant of x. Okay, so the variables are the same. So the first thing you want to ask yourself whenever you're simplifying is you want to say to yourself, okay, so I'm going to say, Mrs. Fry, can I rewrite either one of these things as something else? And I'm going to say to myself, I'm always going to try and shoot for, by the way, I'm always going to try to get things back in terms of sine, cosine, or tangent if possible, okay? That's just how my mind works. So when I'm looking at this problem, I'm looking at this going, well, I know that cosecant could be rewritten as 1 over the sine of x. And I'm going to say to myself, okay, and this negative cosine is still in the numerator. Okay, so if I can do that, I could multiply these together because this is two fractions. Let's make it one fraction. Negative cosine of x times 1 is just negative cosine of x over sine of x. Okay, and then I'm going to ask myself, wait a minute, is this, okay, I know that nothing in there is negative, so like, is this something? Yeah, cosine, I'm just going to keep flipping back here. Cosine over sine, that's cotangent. So this is really just negative cotangent of x, and that's my final answer, right? Because this whole thing, this package, is the cosine of x. I'm sorry, the cotangent of x. Cosine over sine, cotangent. Okay, it's very easy to get those confused. That's why you got to say them out loud, then you're less likely to mix them up. Okay, let's take a look over here. We've got cosine squared. We've got cosine squared x, and then in the denominator we have tangent of x times sine squared of x. If I kind of break this apart, if I look at this, I just use cosine over sine. That is probably related to cotangent as well. But because it's squared, because there's two of them, I would rewrite that as cotangent squared x over 1. And I still have this tangent in the denominator, 1 over tangent of x. Okay, I have more cotangents than tangents right now. So I could rewrite this guy, the 1 over tangent, I could rewrite that as cotangent squared, not squared, but cotangent of x over 1. And then I already have cotangent squared x from the other part of my fraction. So then cotangent to the first times cotangent to the second, that's going to give me cotangent to the third. Cool. Okay, let's keep rolling. Okay, tangent squared x plus 1. This is all in the numerator together. Tangent squared, squareds. Whenever I see squareds, I always think Pythagorean identity. And in this case, my suspicion is right. Tangent squared plus 1 is really just secant squared. So this whole thing right here that I just circled, that is the same thing as having secant squared of x. Okay, so that I'm going to rewrite, and then I'm going to break out the I'm going to break out the 1 over cosine squared. I'm going to write that separately, okay? You don't have to, but I'm just going to write it as its own separate fraction. And the reason why I'm doing that is because I have a decision to make. I can either put everything in the denominator, like I could rewrite the secant, or I could put everything in the numerator. The other thing I would say about your goal is you want to simplify to a single ratio or expression, and you want to keep it whole. Okay, what do I mean by that? I mean avoid a fraction if you can. So like the reason why cosine of x over sine over x wasn't the final simplified is because I could make that fraction whole. I could make it not a fraction anymore. So in this case, if I move everything to the bottom, I'm still going to have a fraction. So instead, what I'm going to do is I'm going to say, wait a minute. Cosine is related to secant. It's the reciprocal. So if I flip that over, 1 over cosine is secant. So the exponent doesn't really matter. So when something is squared, you just change it so that it matches. Since this is cosine squared, I'm going to rewrite that as secant squared. And now, when I multiply everything together, I get a final answer of secant to the 4th of x. Because I rewrote my 1 over cosine squared as secant squared. And if you're like, wait, I'm just a little bit confused on that. Sorry that my thought bubbles aren't super awesome. Secant is 1 over cosine. So we just use this fraction in reverse. We started here, 1 over cosine, and rewrote it as secant. 1 over cosine turns into secant. And just because it was squared, we made the exponent squared as well. Okay, number 4 on this worksheet. Ooh, there's a lot of stuff going on in here. Well, let's break this down a little bit. Again, sometimes I think colors can help. So it looks like I have sine of x in the numerator times secant of x. So that's going to have to change over tangent squared. Okay. First thing I'm noticing right off the bat, this secant, I could rewrite that. I could write that as like anything else. Let's rewrite it as 1 over cosine. We just used that. Okay. I know it's in a fraction, but it's fine. Sine of x. And then tangent squared in the denominator. Okay. Let's see what we've got here. Wait a minute. This top part is really just sine over cosine when I multiply that together. And sine over cosine, that's just tangent. Tangent of x. So notice I took this and I rewrote it as tangent over tangent squared. Well, what happens when I have one of something, you know, one factor of something over 2 factors of something? That can reduce. So I'm going to have 1 over tangent of x. Sorry that I kind of have to go on a little tangent here. Bad joke, bad math joke. Okay, 1 over tangent then simplifies to cotangent of x. Now that's probably not the only way you could do this problem, but that is one way you could get to the answer for this problem. All right, we got a couple more to do before we are done here. Okay, so we got a lot of reciprocals going on in this one. Okay, so we've got tangent squared. And then I'm going to rewrite both of the things in the denominator. Okay, so we've got secant, which is the same thing as 1 over cosine squared. And then we have cosecant, which is the same as 1 over sine squared. Okay, so this might look a little funky, but in the top we have tangent squared, and in the bottom we have 1 over cosine squared sine squared. That is not pretty. But you know what? I don't have to keep it like that. I could take tangent and I could multiply it by the reciprocal. So I'm going to take the reciprocal of that denominator. So I'm going to rewrite that as cosine squared times sine squared. So now everything's over 1. Okay, this is in a much better place. But nothing cancels, so this feels very useless until I rewrite tangent as sine squared over cosine squared. And I copy down what I already have, cosine squared times sine squared. Please excuse my phone buzzing. Give me 1 second, folks. Okay, so the cosines cancel, and it looks like we are left with sine to the 4th power. All right, we are almost done, folks. I'm going to kind of go through these last two a little quickly. Okay, so it looks like I've got secant squared in the denominator. I could rewrite that as cosine squared x by taking the reciprocal of that. And then, oh, check this out. Cosine cancels out one of those cosines, so I'm left with just cosine of x. Boom, shakalaka, that one was done. Cotangent of x plus 1. This is going to take me a second. Cotangent is 1 over tangent. I don't think that's going to be super helpful. So I'm going to use my quotient. I'm going to change that to cosine over sine. And then I'm going to add sine over sine so that I get something that looks like 1. And I'm going to rewrite cosecant as 1 over sine of x. Oh, whoa, everything has a denominator of sine. So let's see, cosine of x plus sine of x over sine of x times sine of x over 1. I took the reciprocal of that second guy. That cancels. Cool. Oh, and then I'm just left with cosine of x plus the sine of x. All right, folks. I hope that me talking to myself has helped you understand a little bit more how to simplify all of these expressions. Thanks for listening. Bye.